Okay, today we are on section 2.2, which is the distributive property. The distributive property is the last property we'll probably look at in this course. There are other properties that you will see later on, but the distributive property will be the last one we deal with, and it's probably one of the most important because we will use this time and time again. It is a very simple thing, and you will be so used to using it by the end of this course you won't even have to think about it. But let's look at what it says. Now let's look at this first problem right here. Okay, what we have is 2 times 90 plus 60. Well, order of operation tells us to do parentheses first. So if I add 90 and 60, I get 150. And then I multiply 2 times 150, and that gives me 300, which is a very simple problem. Now, there's another way to go about solving this problem. And in this case, it's more difficult, but it's going to show us what the distributive property says. Okay, look to the right here. We've got 2 times 90 plus 60. Instead of adding 90 and 60, we're going to multiply 2 by each thing inside of it and separate it by the addition sign that's right here. So I get 2 times 90 plus, because there's a plus sign between them here, and then 2 times 60. Okay, this is the distributive property in use. Okay, so it's 2 times 90 plus 2 times 60. That equals 2 times 90 is 180, 2 times 60 is 120, and that gives us 300, which is the same thing we got over here. 300 on both of them. Now you say, why would we do something that's harder? Well, the distributive property helps us when we got something in parentheses that we cannot add together, like an x or some kind of variable and a number. So it's not always harder. And it also helps us with mental math, which we will see a little bit later. But what the distributive property says, look to the bottom, we've got a times b plus c is the same as a times b, which is right here, and a times c added to a times c. And if the a is on the other side of the parentheses, like it is here, it doesn't change anything. Basically, it's a times both of those things. A times b plus a times c, which is right here. And again, order doesn't matter. So if we have b times a, that's the same as a times b. If it's a subtraction, no problem. A times b minus, right here, a times c. We just use the sign that's in between them, okay? And if the a is on the other side, not a big deal. We do the same thing. A times b, or b times a, minus c times a. Okay, basically we're multiplying what's outside the parentheses by each thing inside the parentheses. That's what we're doing. That's the distributive property. The distributive property is another way of doing parentheses, okay? When you've got something multiplied, like this 2, to the parentheses. So let's look at this a little more in depth. Okay, now these are problems that it would be easier to do without using the distributive property. It would simply be, if we simply just added what was in the parentheses and multiplied, we would get out a whole lot easier with a whole lot less pain. So, but we're learning the distributive property, so we're going to use some of these easy examples just to kind of learn what it is. Okay, and what I encourage you to do when you're first doing this is to make sure you're doing it right. Just look at this first one right here. We got 3 times 8. That's going to be 3 times 8, which is 24. Okay, plus sign comes down between them, and then 3 times 5, which is 15. I just encourage you to put a line as you multiply to each one, like we do here. It helps some of the kids. We do. You don't have to do that, but with some of the kids, it does help to do that. So I have 24 plus 15, which gives me 39. Which if you would have added 8 plus 5, you get 13. 13 times 3 is 39. So it works. Okay, here, multiply the 2 times the 2. We get 4. Bring down the plus sign. 2 times 9 gives me 18. Well, 18 plus 4 gives me 22. And check your answer. 9 plus 2 is 11. 11 times 2 is 22. So that indeed is the answer. Look at the next one. 6 times 11, 66. Bring down the minus sign. 6 times 4 is 24. Now simply subtract 24 from 66. I should get 42 for an answer. Last one of these. I've got negative 5. Negative 5 times 93. Well, 5 times 3 is 15. 5 times 9 is 45. Plus 1, that's 46. And it's negative. So it's a negative 465. Minus, bring down the minus sign. 5 times 14. Well, that's going to be 70. Negative 70, right? Okay, now what happens with these two negatives right here? Well, they become positive. Remember, we change a minus sign to a positive, a plus sign, then we change the sign of the number behind it to positive. So we got 70 and 465. Well, they're different signs, so we have to find the difference. Okay, so we're simply going to subtract. We get 5. We have to borrow 1, right? That gives us 16 minus 7. It's 9. And then that gives us 395, doesn't it? 395. Okay, and it's negative because the bigger number is negative, so I get negative 395. Okay, moving to the next page. Evaluate the expression using the distributive property in mental math. Now this is how I do a lot of my mental math. Notice in the parentheses here I just have one number, so that's not really distributive property. But maybe I can break it up into two numbers that are easy to multiply, and I can do this mentally in my head without having to write anything down. The way I would do this, 105, is I would take 105 and split it up. I would make it 100 plus 5. Okay? Now this is very simple to do in my mind. I know that 4 times 100 is 400. I know that 4 times 5 is 20. And I know that 400 plus 20 is 420. So if we wrote that down, it would be 400 plus 20 equals 420. And if you can do this in your mind, instead of trying to multiply 4 times 105, it is easier to multiply 4 times 100 and then add 4 times 5. So that's using distributive property for mental math, which is I do a lot. It's very handy. So instead of 97, let's change 97 to 100 minus 3. Isn't that 97? Yes, it is. So I can do this in my mind. 3 times 100 is 300. 3 times 3 is 9. We've got a minus sign. What's 300 minus 9? Well, that's 291. Pretty easy when you do it like that. What about 2.9 down here? Well, that's really, who wants to multiply that in their head? Nobody. But could I do this? 3 minus 0.1. That's a lot easier to multiply. 5 times 3 is 15. 5 times 0.1 is 0.5. What's 15 minus 0.5? Well, that is 14.5. That is a whole lot easier to do with mental math and distributive property than it is this right here, multiplying 2.9 times 5. Let's look at 7.02 times 8. Again, split 7.02 up. Let's make that 7 plus 0.02. Well, that's nice to do. I know that 8 times 7 is 56. I know that 8 times 0.02, well, that is 0.16, right? What is 56? Whoops, got parentheses. 56 plus 0.16. So that is just 56.16. That would have been an ugly problem had we tried to do that. Now we can use distributive property and do it mentally without having to really write anything down. I just simply wrote it down so you would see what we were doing. Okay? That is using distributive property for mental math. We take the number inside the parentheses and we try to break it up into two things that would be easy to do. Sometimes it's not, that doesn't work and you have to do something else, but a lot of times it really works. Let's look at when we have to use distributive property. When we have a variable inside the parentheses, now we cannot add the x and the 2 here. They're not like terms. In other words, this is a variable, this is a constant. I can't add them. I could multiply them together, but I can't add them. So we have to use distributive property to simplify this. This is not in this most simplified form. So what we have to do is use distributive property. So that is 8 times x, which is 8x. 8 times, basically this is a 1x, right? So it's 8 times 1x, which is 8x. 8 times 2 is 16. And that is simplified. 8x plus 16. And you're done. You don't know what x is, you can't do anything else. This and this are not alike, so you can't add them together. Let's look at this one. Well, just take negative 4, multiply it by 7, I get negative 28. Minus negative 4 times x is negative 4x. What happens here, we need to fix this. This becomes plus, so it's negative 28 plus 4x. And that's simplified. Okay, nothing difficult, just a little different than what we've done before. Okay, 9 times 3m, I've got 27m. Plus 9 times 5, which is 45. Again, this is simplified, and we're done. Next, negative 2 times 6y is negative 12y. Negative 2 times 4, well, let's put the minus sign. Negative 2 times 4 is negative 8. And what happens to these two negatives? Well, they become positive. That's negative 12y plus 8. And this is simplified. So that is basically how we're going to use distributive property this year. When you have two things you can't add inside the parentheses, multiplied by something outside of the parentheses, two or more things actually inside the parentheses, we can use distributive property to simplify them. Okay, one last thing before we're done. We're going to use distributive property here to find the area. Now the length of this rectangle is 2x plus 5. The width is 7. Remember, area is base times height or length times width. Either one. So the same thing here. We're going to multiply 7 by 2x plus 5, and we're going to use the distributive property to give us our answer. 7 times 2x is 14x, plus 7 times 5 is 35. And we are done. 14x plus 35. We don't know what x is, so we are finished. We can't do anything else to that problem. Okay, remember a triangle, it's 1/2 the base times the height, or it's base times height over 2, which is the same exact thing, however you choose to do it. Let's do base times height over 2. Or we can do, let's do 1/2 base times the height. 1/2 times 12 times 8 minus 3y. Okay, now here, these are all multiplied together. This, this, and this. I don't have to multiply 1/2 by this and 1/2 by this. I can just multiply 1/2 to this. So 1/2 times 12 is 6 times 8 minus 3y. Now I can use distributive property. 6 times 8 is 48, minus 6 times 3 is 18y. That would be units squared on both of those, but since we don't have any units, you don't have to write anything. But that is the area, and that is using distributive property.